Now say that I know sine of theta equals x. Before x was equal to 2/3, now it's just x. Some number that we're not quite sure what it is, but we're just using x to denote it. And then let's find cosine of theta. And of course, another way of writing that, you might see this written as cosine of sine inverse of x. When you see the problem written like this, it looks a little bit unfriendly, but if you know that sine of theta equals x, you just have to remember that that's the same thing as saying that sine inverse of x is equal to theta. And then you've got it. You're looking for cosine of theta. So how can we do this? Once again, I want to try to take what I'm given. Here's what I'm given. And I want to draw a picture of it. So I want to look at a right triangle with angle theta. And I want to find some side lengths. I can choose 2 side lengths, and then the third one will be determined. So I want to find 2 side lengths that are going to give me sine of theta equals x. And so I know that sine is, once again, the opposite over the hypotenuse. So I may as well choose the opposite side to be x and the hypotenuse to be 1. And there's different ways you could draw this picture. So say that I made a bigger triangle. Say that I made a triangle that was twice as big. Well, this one isn't actually twice as big, but we can imagine it is. So say that this side was now 2 times x, and that side was 2. It would still be true that sine of theta is going to be opposite over hypotenuse equals x. And these triangles are called similar. You're similar triangles if the only difference between the 2 triangles is that one has been scaled up in size like that. So there's so many ways to draw a picture of that equation. You can just pick one. I like choosing one of the side lengths to be equal to 1. That just makes it simpler for me. And once you do this, all you need to do is find that cosine of theta. And so once again, I want to use that Pythagorean theorem, and I want to find out what's the length of this adjacent side. So I'm going to take x squared plus adjacent side squared. And that's got to be equal to 1. And now I can just solve this equation. I can pull the x squared to the other side, and that's going to give me adjacent side squared equals 1 minus x squared. So the adjacent side is the square root of 1 minus x squared. And I'll go ahead and write that here. And since I've written that here, I'll erase this part. So I just want to work out what's going to be cosine theta. And I know that has to be adjacent over hypotenuse. So my adjacent side here is going to be square root of 1 minus x squared. And my hypotenuse, that's just equal to 1. So I just divide that by 1. Of course, that's the same thing as just saying 1 minus square root of x squared. And you might look at that and you might say, wait a minute. I know another way to do this. You might say, I know that cosine squared plus sine squared equals 1. Because we just talked about it. And based on this, if you know that sine theta equals x, then sine squared has to be x squared. Solving the equation, you're going to get cosine squared theta equals 1 minus x squared, and then you're going to take the square root of both sides to get that cosine theta is the square root of 1 minus x squared. So for this problem, you could have done that either way. But one thing that I'm really going to be happy if you really understand well is how to draw the picture of the equation and then use this argument to figure it out as well.